Hello everyone. So for this video tutorial, I'm essentially going to show you how to do some basic analyses on a bridge deck. So the next part of this course is going to focus on creating a pedestrian bridge that comes from Dusty Greenwell Park on the south side of our site to this sort of cargo container site that's on the north end of our site. So we need to essentially bridge from this park to make a connection to this side on the north to cross these train tracks and to sort of activate this area as part of the extant park. So to do that, of course, we're going to make a pedestrian bridge. A pedestrian bridge, of course, it has some structural requirements. We'll sort of cover that a little bit later. Not so much the technicalities of structure, but how to make something that looks like convincing structure. But also it needs to meet a few other requirements that we'll cover in this video. So principally, it needs to clear the trains that go underneath the bridge. So I'm going to show you how to essentially just measure how much distance is underneath a different point at different points in the bridge. So you can see here 8 meters. And for assignment 2, of course, you're going to have to make sure that you clear these trains below. It's worth knowing that my site is a simplified version of what you have. I've just put in the one railroad and the one train car to sort of represent the clearance needed. The other thing that we need to make sure is that we have an accessible slope. So what you see here is I have this 6%, 7%, 8%, 8%, 8%, 9%, 9%, so on and so forth. These refer to the slope. And if you're not familiar with percentiles for slopes, essentially it's quite easy. It's rise over run. So let's say we have a length horizontally that goes like this. We have a height that vertically goes like that. Essentially, this height divided by this length will give us a percent. So let's say this is 2. Let's say this is 4. 2 divided by 4 is 0.5. So that would give us a 50% slope. So what you want for an accessible slope is actually something closer to 1 to 10. So a 10% slope is kind of the standard accessible slope. This lets people with mobility constrictions, restraints, easily walk up the stairs, and it also just makes a nice path to walk. So you can see here that what I've done is any percentage which is less than 10%, so it's a nice subtle slope, is green up to and including 10%, and anything that is greater than a 10% slope, so we have some 11s here, is red, so kind of a stop. And what we're going to do is we're just going to draw a simple line and plan, and we're going to modify it. And in this way, it'll allow you to sort of flexibly play around with your bridge on the site, so you can best position your bridge on the site. Within Grasshopper, we'll also work on changing its vertical orientation. So I'm just going to make this window smaller so we can really focus on Grasshopper. So for instance, you can see here that this bridge is quite diagonally constant, but we're going to work with a method using something called the graph mapper to be able to move it up like so. So if we need more clearance here, we can move the bridge up, but then you also have the problem that it's going to get steeper. So to fix that, you can, make your bridge longer, but then who knows, maybe you're intersecting with a building or something. So these are the kind of issues that you need to kind of, move between to create a really interesting bridge. So of course, we won't be doing any financial analysis in this class. So, I mean, budget is not a thing. So what you'll need, the requirements you'll need to meet are clearance over the tracks and a 10% slope for your bridge. So this tutorial is just going to cover the basics of how to take this curve in 2D, span from point A to point B in a flexible parametric way, and then how to measure your slope and your clearance. So I'm just going to disable my notes here. So essentially what we're going to do is when we're looking at our site here, I'm just drawing a curve for the bridge. So this is going to be the center line of the bridge. And essentially what I'm going to do is I'm going to draw just a normal control point curve. So if you just click on the little control point curve icon here on the left, at least this is a good way to start. Maybe you'll change it after. You're just going to draw something like so. You know, you can have a slight other twist. It doesn't really matter. I'm going to stick with 4 points. And this is just going to allow us to sort of move this curve in different ways so we can adjust our bridge. The other thing we want to make sure is that this control point curve is above our surface, like so. So if it's not, if your control point curve was drawn down here, just grab it using the gumball, lift it up above. It doesn't really matter where. We're going to be projecting this down to intersect with the surface anyways. Of course, we're going to reference this in Grasshopper. So we're going to go to Params, Geometry, Curve. I'm going to right-click my curve input, choose Set One Curve. And now if I select the curve component, you can see that the curve is indeed referenced. So now we can go to our component in Grasshopper. Just going to minimize this a bit. Now we're going to go to our curve component in Grasshopper. We're going to right click it and we're just going to name this input curve. You might actually want to choose something a little bit more descriptive, like for bridge plan. Great. So essentially what we're going to do now is we are going to take the ends of this curve and we are going to draw a line straight down from these ends in order to find the intersection from the ground. So that's going to give us our bridge beginning and our bridge ending. So to do that, we're going to go to Curve, Analysis, and then we're going to go to Endpoints. So that's Curve, Analysis, Endpoints. And now you can see we have 2 little X's for our points right there. And one thing you can do is to figure out which one is the beginning and which one is the end. We can just go to Params, Geometry, Point. And we can plug our start output, so our curve start point, into our point component right there. And you can see that this point is indeed my start point, and we want this to be the start point. So if your start point is over here, let's say, you drew your curve backwards, that's fine. What you can do is in Rhino, you can select your curve and you can type the command flip. So flip, and now you see it'll change the direction of your curve and the start will be on the alternate side. So again, select your curve, flip. So you just want to make sure that your start point is in the Dusty Greenwell Park. Once you've confirmed that that's the case, you could maybe leave this point component off to the side, but I'll just delete it for now. So now what we're going to do is we're going to find the intersection point between this point on the surface and the end point on this surface over here. So to do that, we're going to draw vertical lines from these points. We're going to go to Curve, Primitive, Line SDL. So Curve, Primitive, Line SDL, which stands for Line Start Direction Length. So the inputs are start. That's going to be our point. Direction is going to be our direction. In our case, it's going to be down. And our length is going to be, you know, an arbitrary length that it intersects with this surface. So we're going to put our start point into Line SDL. And then following that, we're just going to copy this component, so we can go Control C, Control V. We'll keep these things separate for now, and we're going to plug our endpoint into the second line SDL. Now what we're going to do is we are going to create our downwards vector. So we're going to go to Vector, Vector, Unit Z. And so this is unit Z, it's the Z vector, so that's straight up in our world coordinate system. And our unit multiplication by default is 1, so that means straight up. So what we can do is we can right click the F input and go to set number and change it to -1. Click the question mark or the check mark to commit changes. And now you can see our vector is 0, 0, -1, so straight down, and we'll plug this vector into our 2 direction inputs. Now, finally, you can see we have these 2 little curves drawn here, and we actually don't need to worry about changing the length. Technically, we didn't have to worry about changing the direction of the vector either. I just did that because maybe it's a little bit more intuitive while you're learning Grasshopper. But essentially, the kind of intersection we're going to look for, essentially what's going to happen is we're going to use a mathematical intersection. And what that means is that Grasshopper is going to look at this line, and rather than looking for an intersection between this surface and this line on a physical level, does it physically intersect? It's going to look at this line as an infinite ray moving in both directions. So it's going to go infinitely up and infinitely down, and it's going to look for an intersection between the surface and that ray right there. So that's the next thing we're going to do is we're going to look for the intersections between those lines and the surface. Before we can find the intersection, we need to reference our surface here. So what I'm going to do is I'm going to go to Params, Geometry, and then I'm going to choose Surface. So surface right here. I'm going to select my surface. I'll right click the surface input and I'll say set one surface. Then I'll right click the surface component, and I will rename this ground surface just so it's a bit more descriptive of what we are referencing. So once that's done, now we can look for the intersection between these lines and this surface. So to do so, we'll go to Intersect, Mathematical, and then we're going to go to Surface Line. So that's Intersect, Mathematical, Surface Line. And this has 2 inputs, so base surface and the intersection line. We're going to double this up for now. In the future, we'll sort of look at how we can reduce the amount of components we're going to use. So for example, using 1 intersection component instead of 2. But for right now, we'll just copy it over and sort of keep them in different streams. So I just selected my surface line intersection, type Control C, Control V to copy it down. And after that, we can just plug our ground surface into both of the surfaces here. So the surface inputs of SLX. And then we'll take our lines, so our start line, that's this one over here, plug it into the line input. And then our line component, the end line right there, we're going to plug into the line component. And then what you can see is we get these 2 intersection points on the ground right here. So what we're going to do now is we are going to essentially divide this curve here, and then we're going to figure out the Z value of these endpoints on the ground right here, and then we're going to map all of the intermediate points to a range of values that are in between this Z value and this Z value here. So it's a little bit difficult to explain, so it's probably best to just sort of watch ahead, see what we're doing. At this point, too, you know, we might want to group this So let's group all the work we've done, and we can just right click this group and we'll call this finding the end points of the bridge. So what we're going to do now is we are going to create a domain. So we're going to say, what's the high point of this bridge? What's the low point of this bridge? So the elevation of the beginning, the elevation of the end. And to do that, we have our intersection points here. So if we click on our first surface line intersection, that gives us the beginning of our bridge, surface line intersection, the end of our bridge on the ground. And we're going to figure out its elevation by going to vector, point, deconstruct. So again, that's vector, point, deconstruct. And we'll plug our our beginning point, which is on the ground, this one here, into the point deconstruct. And we will plug our final bridge point, which is on the ground there, into the point deconstruct. Now, if we look at the Z values, we can see that our start has an elevation of 18.19 meters, and our end has an elevation of 5 meters. So there's about a 13-meter drop, which is quite a sizable drop for a bridge. Luckily, we have a lot of space. So what we're going to do now is we're just going to create a domain going from 18.19 to 5. So we'll go to Maths, Domain, Construct Domain, and we'll plug in our beginning, 18 point whatever, yours might be different, and our final value for our endpoint, Z, I'll plug into B, and this will give us our domain of 18.1 to 5. And I'm going to pause now to stop some barking dogs. Alright, so we have our domain here, and essentially what we're going to do is we're going to create a list of points along this curve, and then we're going to replace their Z values with Z values that fall within this domain. So first thing we're going to do is we're going to divide this curve. So we're going to go to Curve, Division, Divide Curve. And we'll just put that down on our canvas a little bit lower. Now, we have our original input curve for bridge plan. What we're going to do is we're going to drag out from this reference curve. So again, that's referencing our original curve we've drawn in plan. We're going to take our input curve for bridge plan and we're going to plug into our curve input in the divide curve component. So C, curve to divide. And then we are only really going to worry about this input here, so number of segments. You can see what that's referring to is the number of segments between these points right here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're just going to create a slider to sort of reduce or increase the amount of segments we have, because this is essentially going to give us a control of our resolution. So are we checking the slope between these points, or are we checking the slope at every, meter on the meter? So to create a slider, again, the quick way to do so is just to double click on your canvas, and then we'll just type we'll say 0.1. Oh, actually, no, we won't, because this is the number of segments. We will type integers, so we'll type 1, so minimum 1 segment. 2, we'll say maximum 50 segments. So 1 less than 50. Hit enter. And now we can plug that into N, so number of segments. So you're definitely going to want more than 1 segment, so why don't we just, for right now, increase it to 15. So now that we have these points, what we're going to do is we're going to decompose these points in the same way that we deconstructed these points here. And we are going to essentially replace their Z values with values that fall between the Z values of the start and end points. So in order to do that, first we're going to deconstruct these points. So we're going to go to Vector, Point, Deconstruct. and we'll plug our division points into our point deconstruct. So now you can see it's giving us the x values, the y values, and the z values of these points. And then what we're going to do is we're going to reconstruct them now. So we're going to go to vector, point, construct point. And we want to keep the x value the same. So that's x is this direction, I think. Y is the perpendicular direction, so this direction. But we want to replace the z value. So what we'll do is we'll take our point deconstruct. We'll plug x into our point construct x, y into our point construct y, and then you'll see what happens is by default the z value is 0. So what it's doing is it's just creating our same points but essentially projected to our C-plane, so an elevation of 0. So that's good, and this is where we're going to leave it for now because we need to figure out what the z value of these points are. So an easy way to do this is just to create a range. So what we're going to do is we're going to go to sets, sequence, and then we're going to go to range. So that's sets, sequence, range. And range, if we hover over it, it's create a range of numbers. And what that means is given a certain domain, so you can see domain is the first input. Let's take our domain that's between the elevation of the start point and the elevation of the end point. So domain, we'll plug into domain range. And you take that domain and you divide it by a number of steps. And it's going to give you numbers that are equally spaced between those extremes in your domain. So our domain is coming from our start and end elevations. And our range is actually going to come from the same slider that's divided our curves. So we can take our slider and plug it into n. So now this is going to give us 16 z values for our 16 points. So now, once we've done that, we can take our range and we can plug into z. And what you'll see is that your points are perfectly arrayed between the start and end points. So right now we have a constant slope between these points, and you've taken your 2D curve in plan and sort of arrayed it down on the angle needed to span from the beginning of your bridge to the end of your bridge. So that's some pretty neat stuff. What we're going to do is we are going to, I'm just going to tidy up here a little bit. So at this point, I'm going to rename this slider we made. So I'll right click it and I'll just call this bridge curve resolution. And what I mean by bridge curve resolution is that we're going to take these points and draw a curve through them. So you can imagine if we're drawing a curve through all these points, our resolution's going to be quite high. Our curve and plan is going to look quite similar to our original curve right here. But let's say our resolution was brought down to, let's say, 2, and I'm drawing a curve from this point to this point to this point. You can imagine that Rhino wouldn't know how to quite trace this curve and plan. So the higher the number, you know, at least in theory, the higher the resolution. Usually, you know, I just kind of play by ear to see what looks best. So what we're going to do is we're going to group all of these things we've just done as well. I'm just going to drag down all this, and I'm going to name this group. So getting curve points between start, I'll say bridge start and bridge end. And what I'm going to do right now is I'm just going to pause the mic, and I'm just going to leave this on the screen for, you know, 15 seconds or so, just so you can actually sort of rebuild this if you're catching up. Now, the other thing, if you see a component and you sort of don't know what it is, a quick way to do this is you can see, for instance, right here, it's pdecon. You can just look that up, pdecon. And then it's going to go deconstruct point, And then if you want to find where that is in the tab, of course, you can hold Control and Alt and click that component, and it's going to tell you exactly where it's located. So I'm just going to pause my audio for 10 seconds. All right, so we're going to move on from here, and what we're going to do is we're going to figure out a way to essentially manipulate these points in elevation. So maybe you actually don't want to have this constant slope. Maybe you actually need to increase your bridge right here for clearance issues. So maybe you want to push these points up at certain points. So we're going to do that. What I'm also going to do right now is I'm just going to preview off everything except for my points right here, just so it's a little bit clearer to see. So what we're going to do is we're going to use something called Graph Mapper, and we're going to use it to push our points up. So essentially, we're going to go to Params, Input, Graph Mapper. And essentially what Graph Mapper does is it takes a range of numbers, usually between 0 and 1, that's kind of what I always use as, and it applies a visual graph to it to change the value. So if you right click on Graph Mapper and go to Graph Types, let's go to Bezier. So that's Graph Types Bezier. And what you're going to see is you're going to see that all right, dogs are crazy this morning. So essentially what Graph Mapper does is it's going to take a list of inputs and it's going to change the values based on a graph right here. So for example, if we were to type in a list of numbers between 0 and 1, so let's go 0, 0.25, 0.5, 0.75, and 1. And we were to, just getting rid of that extra space, we were to plug that into our Graph Mapper there, you can see what happens is 0 is right here, so indicated by that red vertical line, 0.25 is here, indicated by that vertical red line, and so on and so forth for 0.5, 0.75, and 1. And essentially what that's going to do is it's going to find the intersection between that vertical line and the x-axis. So the input is the x-axis, and it's going to assign it a value based on the intersection. So in this case, let's just grab a panel and see what the output is. You can see that 0 intersects at 0 in the y-axis, so it gives us 0. 0.25 intersects with 0.25 in the y-axis, so it gives us 0.25. So on and so forth. So this is a linear relationship. So input's going to equal output, but if we start adjusting these little control points, then essentially what you'll see is now, for instance, 0.25 is closer to somewhere below 0.1. So 0.25 in equals 0.07. So it's just a nice way to sort of define in the case of the Bezier curve, kind of a nice subtly curved, smooth curved relationship. So we're going to use this graph to essentially change the elevation of our bridge. So I'll set it down to just all 0 like that. I'll delete these panels. But what I'm going to do now is I'm going to take the amount of points I have, and what I'm going to do is I'm going to use Graph Mapper to just add to them. So what I mean there is what we'll do is we're going to create another range of numbers. So we're going to go to Sets, Sequence, Range. The domain's going to be 0 to 1, so by default it's 0 to 1 in the range component. Also Graph Mapper works best with 0 to 1. You can change it, but I find it's easiest to work with it this way. And then the number of steps is again going to be our bridge curve resolution slider that we have right here. But what we're going to do is if we look at our points, we have 17 points. We have 17 numbers here. We're just going to take this range and we're going to plug into the graph mapper. And now you can see all the vertical lines. We have one vertical line for each point. So essentially what this is going to give us is an input of between 0 and 1 and an output that right now is all 0. For instance, if we were to change it like that and this, now our output would be all 1. Or, you know, of course, we could have some relationship kind of like so, you know, our output is variable depending on how our curve is moved. But what we're going to do is we're going to take this value between 0 and 1 and we're going to multiply it by a bridge offset. So what we're going to do is we're going to create a number slider. So I'll double click on my canvas. I'll select a range. We want these to be floating point values, so we'll go 0.001 less than, let's say, a maximum of 5.000. We're working in meters, so, you know, this makes sense. Let's hit enter. I'll rename this slider bridge elevation. We'll move up, for lack of a better term. And essentially what we're going to do is we're going to multiply this value by this slider value. So we'll go maths, operators, multiplication. And then now what you can see is if our value is 1 in our slider, the outputs of the graph mapper are going to be the outputs of our multiplication. But let's say we change this to 5. Essentially what we're saying is that everything in the graph mapper is going to be multiplied by 5. So if we move this point up here, we know that when we get an input of 1, it means that our end value is going to move up to 5, because 5 times 1 is 5. And play around with the outputs here just so you can get a better sense of what's going on. Probably it's going to be a little bit more apparent when we start moving these points, so let's do that. We are just going to grab a vector, so we want to move up, so we're going to go to vector, vector, unit Z, and we are going to take our multiplication result, plug it into unit Z. So now we have our values. They just have a direction, which is straight up. And then we're going to go to transform, Euclidean, move. And then what we'll do is we'll take our geometry, which are our points coming out of our points between bridge end and start group. We're going to take our points output, plug it into geometry, and then we'll take our vectors coming out of the graph mapper and put them into our translation vectors. And you can see what's happening here is that at the end, since we're moving the end of the bridge up by 5 meters, what's happening is it's just moving up like so. But of course, unless maybe in your design you want your bridge to end at an elevated platform, then this could be quite useful. Probably what's going to happen for you is that you're going to do something like this. So you're going to set the ends at 0, so you can see we launch from the ground, we end on the ground. But maybe you just need to adjust the height at this point. Then what you might do is you might take your right control point, decrease it, and then if you look at the Rhino screen while I'm moving the Grasshopper screen, as I move this up, you can see we're just pushing our bridge up ever so slightly to help us move over this area, which really needs a lot of clearance. So that's just how we can adjust our elevation of our bridge points. Of course, if you need more elevation, you could always change the domain to your slider. So, you know, if you increase it to 20 meters, for instance, you could start to get some quite radical, you know, slopes going on there. So, now that we've done this, what I'm going to do is I'm going to preview off my points, these constant angled points. I'll preview them off. And then I'll group these points, which are moved up in elevation, and I will call this group points modified in both plan and elevation. And this is going to be the basis for our bridge. So what we can do now is very simply, we can just draw a curve through these points, and then we can offset that curve to sort of get our bridge deck. So what we're going to do is we're going to draw the curve through all the points now. So we're just going to go to curve, spline, and then we're going to go to interpolate. And then we're just going to take our moved vertices, so our moved points, and we're going to plug into the vertice input of our interpolate curve. And you can see that just gives us a nice curve like so. Maybe I'll just bring my bridge back down a little bit. It's sort of giving me vertigo looking at it. So there's our nice kind of more accessible bridge. We have our interpolate curve. And what we're going to do now simply is we're going to offset it. So we're going to go to curve, utilities, offset curve. We'll plug our interpolated curve into the curve offset input, so the curve input rather. And you can see what it's doing by default is it's offsetting, and also by default it's offsetting in the XY plane. So if you hover over the plane input, it's world XY. So that's good. It means we're going to have a totally flat bridge, no cross slope. But what we want to do is we want to offset on both sides so that this remains the center point of our bridge. So what that means is we're going to grab a slider. So I'll double click on the canvas, and I'll make a range of numbers from 0.01 to let's go 5.00 and hit enter. I'll right click this slider and call it bridge deck width. And then what I'm going to do is, since this is an offset here in the positive direction, I want to offset in the positive direction, also the negative direction. So what I'm going to do is I'm going to go to maths, operators, and then negative. And then I'm just going to plug my slider into the negative input, and now you can see a value of 1.76 from my slider. It gives me a value of negative 1.76 from my output of the negative component. And what I'm going to do is I'm going to hold shift to get the little green arrow with the addition sign and plug it into the distance input, both of them into the distance input of my offset component. Now, one thing to keep in mind is that this distance is offsetting 5 units this way, 5 units this way, when really what I want is an overall width of 5 units. So what I can do to rectify that is I can just right click on the distance input. I can go to expression, and I can go to x divide by 2. And now that'll just offset by 2.5 on both sides, giving me an overall width of 5. Now simply what I can do at this point is I can loft between these two curves to give me my bridge deck. So I can go to surface, freeform, loft, and I can plug these curves into the loft. Now you can see that we have a dashed line here, which means that this data has been grafted. So if we hover over our curve output, you can see, of course, we have 2 branches there. So one that has a path of 0000, one that has a path of 0001. But what we can do is we can actually just right click this and go flatten. That will put both curves in one branch, so Grasshopper will consider them fair game for a single loft. and you can see it simply lofts between those two curves like so. So this just gives us a good start to our bridge deck. It's still a bit abstracted, but we have a nice curve that doesn't have a cross slope, so it would make for a fairly good bridge. Now what I'll do is I'll just select all of these components. I'll right click, I'll go group, and then I will label this group creating the bridge deck. And again, what I'll do is I will try to give you an overview of the entire definition so you can sort of take a moment and sort of make yours look like mine. I'll make it as big as possible. Alright, so at this point, what we have here is we kind of have a fun little tool that allows us to create a bridge deck that if you grab your control curve, you can see you can move it around, your bridge is going to automatically update. Of course, you can bake this and start to put some rails and everything on it. We'll cover railings in class. But I'm going to leave the analysis part for the next video, because I see this is already starting to reach around 40 minutes, which means probably takes about an hour and a half to work through. So I'll leave it at this, and for the next video we'll do the analysis. So if you have any questions, feel free to email me. Thank you.